Yeah, first off, everyone, thank you so much for being here. We're super excited to host this and to be involved with Dronecode. We're obviously big proponents of open source. We're here because of open source. The fact that more companies don't pay more of an homage to that is kind of a disappointment, honestly, because we go faster together, right? And we're all sort of working in the same sphere. So if we can contribute back, make the ecosystem better for everybody, that's what we should all be working on. So you're here at Firestorm at our HQ. We're quickly moving from here. This is about a 15,000 square foot manufacturing facility and office, and we're moving to about double that in the next few months. So that's exciting. So you caught us here at our old digs. Next one we'll have at our new digs and have more space for everybody to come by. Here's us. So this is the founding team. So Dan and I found each other through a Navy SEAL friend of ours in about February of 22. It was like in the run up to the war in Ukraine, which was kind of interesting in the arc of our company. Dan had done stuff in the counter UAS space. He founded Citadel, which got sold to Blue Halo. I was mostly in the additive space, and so we connected through some shared experiences with the SEALs. But it put us on this interesting arc with everything that was going on geopolitically at that time, where Dan's experience in counter-UAS told him, look, the modification to drones is going to be a big problem in how wars are fought in the future. And so that was the kind of I guess the impetus for us getting together. My experience as an aerospace engineer and then kind of additive manufacturing SME across a bunch of different technologies and processes and materials. And so we kind of got that experience together and we're like, well, let's do something interesting in the drone space, which to us was, hey, can we do something really low cost and attritable and really focus on fixed wing because, there's lots of great stuff going on in the multi-copter space, but we wanted to exploit what maybe wasn't going on in the fixed wing space so much. We added Chad as well as our third co-founder who kind of, closed the circle, closed the loop on everything that we're able to do as a founding team as the guy who had actually been out there and done it as an operator. So 17 combat deployments, tip of the spear, tier 1 special operations guy, and not like a door kicker. I mean, he also does that, but a very intelligent guy. And so he's sort of our North Star. He's the guy who's been out there using stuff. So as we can build features, tools, capabilities that make his life easier, even being retired now a few years, that's a great direction for us to go in. And then we layer on all the guys that are still active using new technologies. Probably many of those of folks that are in the room. Doesn't just have to be defense related stuff. They're using all kinds of commercial technologies as well. So that's our North Star. We've added, since the three of us, about 51 people, I think. We're about 55-ish now. Growing like crazy. That is a nice segue into, we have 14 positions open. So if you or anyone are looking, definitely come find us out and see if there's a position that fits. Look, I mean, we're working across so many dang products at this point. We need all the bodies we can get, and it's a really exciting time, as everyone knows, in UAS. It's probably you go through the Gartner hype cycle of development, and I think we're truly on that slope of enlightenment right now, where it's just everything all the time, everything autonomous that you can possibly do. We can't do enough of it. So, screw competition and all that. Competition is actually great in this case. We can't build enough drones to fit the need right now or fill the need. So for us, it's let's just work together as much as we can, partner with folks that even seem like maybe direct competitors, and just really push the entire industry forward. And so again, just couldn't do it with open source. So I'm really happy and thankful to anyone here who's open source contributors, all of that, that have kind of helped pave the way for us getting to this point. We started out looking at this in the fixed wing space of, aerospace engineers particularly, really any engineer, right? We like to optimize a solution to a problem and make the very best solution to fit any need that is arising with a set of requirements. How we kind of reverse that logic a little bit is kind of doing the more jack of all trades approach. We wanted to create a fixed wing UAS and a family of those systems that are kind of an underlying architecture, a common architecture, and then an entirely modular ecosystem around that. That's of capabilities, that's of reconfigurations of the vehicle, that's of launch modalities, that's payloads, software integrations. I mean, everything under the sun with a common architecture tying it all together, and that's both software, firmware, hardware, all of the above. And kind of like the big kid Lego building blocks approach to UAS development, sort of driven by the way that we manufacture, which is entirely additively manufactured aerostructure, and the size of our build unit. So it kind of constrained us to about a 15-inch part. That meant that we had to have this very kind of modular approach to building the vehicle. Because of the way that we build our vehicle, additive, right, is on par for, say, like injection molding per part, more expensive. However, we don't have the lead times associated with tooling. We don't have the costs associated with tooling not being quite correct and needing to reconfigure tooling or maybe remake tooling. If it's not something that you can either weld on and remachine or it's a negative to your mold and so it's not going to impact you, you're going back to the drawing board. You also have to design all those molds. That's cost prohibitive as well. And so what we've been able to do with an entirely additively manufactured aerostructure is really change our drone like thousands of times with paying a very, very low cost penalty and lead time penalty. So we're on about the 10th major rev of Tempest right now, which is the vehicle you see here. It's our big Group 2, small Group 3 vehicle. That's about 55 pounds to 75 pounds for people that don't know the groups. And it's been really unique, right? It's cool to live in a space where we can almost develop hardware at the speed of software. Nuno and team are beating us now, but there was a crossover. And then really what you're seeing on the screen here is our mobile manufacturing or expeditionary manufacturing cell, which we call XL. And so that brings in another key competency of ours, which is, okay, we can manufacture it all right out here in our facility. We can do it distributed with our partners, but let's also do it like right near the point of need. So when the operators are saying, hey, today this works, but tomorrow that isn't working, and the other guys that are stuck with hard tooling are like, oh, we can duct tape that capability on or whatever it is, we're like, no, we'll 3D print you a perfect, nice aerodynamic housing around that, and you'll have like a really production level capability in 24 hours versus the lead time to make tooling, yada, yada, yada. So that's really what we're creating here. A few capabilities, and I'll kind of dive into them a little bit more. It's pretty obvious, right? I know sometimes like conflict and defense can be a touchy subject. I mean, the way that we look at it is, look, like Europe is at war. Like we can act like they're not, or that it's defined to one area. But when you have like CEOs like potentially getting murdered in Germany, and you have these things going on, like Europe is at war. So we can't kid ourselves. There are boogeymen in the world. Now we definitely have the standpoint of like we wanted to create democratized deterrence. You won't find any like warmongers, especially with a guy who's gone and fought his whole life. He's not doesn't like war, doesn't want war, but we have to be realistic with what we're facing geopolitically. And we like to look at it as like if we can create deterrence for non-nuclear allies, like how could Ukraine have deterred Russia from making the move that they made if they were sitting on 1 million armed drones as a deterrence mechanism? I don't know, maybe, and that's sort of what we want to enable for our allies. Today, as I kind of alluded to, look, carbon fiber, all these fancy materials, amazing. Like they're wonder materials. I love them personally. It sometimes pains me that we can't build in these materials or that we don't. But it kind of ties it hobbles you a little bit, right? You have to create tooling. Again, if that tooling changes, there's issues with that. It sometimes drives up cost because now you have effectively like artisans sometimes laying your carbon fiber. If anyone's worked with it, it takes a little bit of time to get up to snuff on that and to be able to be a great composite layup person. And then the time that it takes between both creating your tooling, the design of that, sometimes you can now 3D print molds, et cetera. So there are ways to kind of short circuit that. But these are kind of what we've taken from our space, which again is kind of like Group 2, Group 3 fixed wings. And we can do better, essentially. And it's not saying that these systems that are kind of built in these types of timelines and for the cost aren't great. Some of them are fantastic, and they do the job that they are built to do better than anything. But our approach, again, is more of the jack of all trades route, and that's really what we're trying to do. So we're looking at the industry limitations, which, like you have a drone, it can do a certain level of performance with a certain payload. It's sometimes somewhat modular, but usually that means swapping out like a gimbal or something like a component level modularity. Some folks, unfortunately, and I think people are sometimes moving away from this. I think we're trending in the right direction, but there is vendor lock. You know, you get in with a certain manufacturer, and it's like use our stuff and only our stuff. Again, like engineers are engineers, so they're optimizing around a certain mission. That's just the reality. And then the high costs are incompatible with how quickly things are changing. You know, when we were in Ukraine, you're looking in these hangars, and there's like $300,000, $500,000 drones just sitting there collecting dust because Ukrainians were like scared to use some of these systems because they were so expensive, and if they crashed it, it's like, oh my gosh, that's my boss is gonna have my butt. But also, it's just that the evolution of warfare is changing so quickly in Ukraine that if you try to go fight with the technology of yesterday, you're just behind the enemy. They've already figured out an EW attack to take your drone out, and you don't have countermeasures, et cetera. So you have to play that cat and mouse game, sort of on the scale of like daily, maybe sometimes hourly, and that's sort of moving into Firestorm's modular UAS or MUAS. Where we're looking at overmatch across the vehicle. So we have our common architecture. We're generally jet powered by default, but we also have an internal combustion pusher prop option. We have electric options, all without changing the entire architecture of the vehicle. So swap out an empennage or tail section, and you have a different propulsion solution. Yank out a fuel tank, replace it with a battery array. You go from a fuel burning to an electric solution for your propulsion. And we think that that's really exciting because, again, within that common architecture, you have something that maybe is limited in range to something that has phenomenal range, 12 plus hours, with all kinds of different performance capabilities as far as speed, et cetera, where you may be playing that cat and mouse game with what is the attack mechanism that's coming after me as a drone? Is it EW? Is it something kinetic? And how do I kind of get away from that? We have a partner-first ethos, and we integrate early and often. We're not here to develop the best of anything. I like to say that we kind of want to make like the Sam's Choice offering, so there'd be like a Firestorm offering out of the gate for, say, like alt-nav. But that doesn't mean that we're not partnering with KEF, with Vermeer, with everyone else who makes an alt-nav or a vision-based navigation system. And that's across everything. Like, so if you are here today or you're listening to this and you create an integration, whether it's software, hardware, sensor, et cetera, much like Pixhawk, right? Like, we want to be open to all of those sensors, all of those capabilities, and be really a partner for some folks that might not be an OEM with the vehicle platform, but they have a really unique solution that gives our warfighters and other folks a capability that they otherwise wouldn't have. And then again, multi-mission supremacy. If we can take off with our jet vehicle, go do a mission, come back down, swap out empennage, have our now an ice pusher prop, go do 12 hours aloft, an entirely different mission segment, we are giving that operator something that they've never had before with the same control system, same operation, low cognitive load, so they're not constantly having to like retrain and keep current on all these different systems. Right now, if someone in the Army has to use something from a sort of multi-copter group 1 all the way up to group 3s, they're probably working with 10 different companies, 10 different operating systems. It's a lot for our folks, and our warfighters are smart, but we need to reduce the cognitive load as much as we can. And then, as far as our production goes, we like to call this like elastic scalability. So we're not always going to have to produce 1,000 drones per month, but if we do, we have the pathway with our partners. Internally with ourselves and with Excel to rise to that production very quickly and elastically without having to have thousands of our big industrial printers just sitting collecting dust for the months where we're not printing that. Tempest 50 is our kind of our like main core UAS right now. You're showing it in a configuration where it's got the internal combustion pusher prop empennage, but again, that's modular and we can swap that out as needed. There's a bunch of different missions that we're going to have to fly, right? And we want to be able to attack all of those missions with the same architecture. Tempest 50 is not exactly 50, so that was like a nominal. We need to change that. It's more like as I said, 55 to 75 pounds a maximum takeoff weight. Carries a 10-pound payload, and again, carries about 11 or 12 liters of fuel, and then or a big battery array that just replaces the fuel tank section. Bunch of cool IP and whatnot we have on this vehicle, but at the end of the day, it's a tube and wing, right? Like, what are we really good at producing? What does every airliner look like? Why do they look like that? There's a lot of good reasons. It's tube and wing. Like, we could go and make cool flying wings and all that, which are awesome, and I love everyone who's working on that stuff. But this was about like simplicity of design and repeatability. Here's showing our modular power plant. So we actually have EDF there, turbine, and then ice pusher prop. Again, kind of like some people can see our vehicle out here, but patent pending, actually no, patented now, technology around how we actually connect sections together, all built around the operator first mentality that we have here of being toolless. So if you're out in the field and you need to swap sections of our vehicle, reconfigure it, it's usually no tools, and it could be only a couple few tools needed to entirely reconfigure an aircraft, which is super cool. And then transportable, right? Like we wanted to be able to take this thing on a passenger aircraft, even it's a pretty dang big aircraft. It's about an 8-foot wingspan by 6.5 feet in length, but it fits in a pretty nice carrying case because again it breaks down into like modular Lego pieces. Throw it in that case, put it on everything I think up from a 737 it'll fly on, and take it wherever you need it. El Nino is our new entrant into the market. It's our Group 1. So again, a fixed wing vehicle here. This one is kind of again built around our operator first mentality, but really how can any operator out there carry a system around that becomes either one way attritable, an ISR asset, et cetera, but just gives them a little bit different mission profile, flight envelope than say the multi-copters out there. So a little bit more efficient flight profile, et cetera. Not that we're carrying vastly different payloads, but a sizable payload for this type of a vehicle, about 2 pounds. It's going to be about an 8-pound vehicle overall. This is still in conceptual, but then breaks down again to a nice size that any operator can stick on their kit, carry around, and give them an individual capability that they don't have or didn't have before. All controlled via attack, and if people don't know, that's tactical awareness kit. And really we wanted to, again, make sure that all this operator is doing is like telling this vehicle where to go, what to do. They're not sort of manually flying it, et cetera. It's all automated. This vehicle is pretty cool. We got some patents around our thrust vector control, which allows us to do vertical takeoff and landing. You see our patented winglets as well, which kind of allows us to sit on these cool kickstands, be able to be placed out remotely, launch as needed. So anyway, just again, we're expanding the family of systems. Tempest, El Nino are our core ones, and then we're going into a bunch of tube launch systems as well, and then climbing the ladder of weight classes as well, going to like a 250-pound fixed wing UAS too. So lots of cool stuff coming out there. Octra is really cool, I think, and important for this crowd. Octra is really like our, it's our Pixhawk, our Orange Cube, like you name it. But really, in the fixed wing space, a lot of this ecosystem has been built around multi-copters. And so, when we're out there just grabbing, autopilots and flight controllers off the shelf, a lot of times you're dealing with, sometimes only 8 PWM channels, and it's like, well, I have 7 control surfaces, so that rail's totally gone. So, on the multi-copter side, there's more trade space there, and just we don't have that on the fixed wing side. And so there's a bunch of learnings that we were having like that, around using the COTS stuff and then figuring out what wasn't going to work quite right for us. And so Octra is kind of this, it was a little bit of a misnomer, but one chip to rule them all. It's really like one board stack to rule them all, but that didn't sound as good. So it's really this like kind of continuous evolution of a flight controller plus mission compute plus power management plus I/O that allows us to be a little bit modular with the way that we build our board, again, mostly focused on fixed wings. However, with a separate power management board and a separate I/O board, configurable for any vehicle out there. So this is, again, competitive with a lot of stuff out there, but like we see it as not like not a risk to our partners and friends. It's just another offering out there. So we work with the Ecopilots of the world, and in the past we've worked with Pixhawk and stuff. Sometimes we can't do that because our hands are tied with NDA compliance and these sorts of things. But again, this is mainly to be an offering in the future where we can dog food this internally and use it, and then put it out there as a product for other folks to use, enabled by some of the software that we're building to make it simpler to get up and running with our vehicles. Warrium, how am I doing on time, by the way?
We got 10 minutes.
10 minutes? Awesome. Okay, so War Room is another offering that we had, and this is basically to take missions, to be like a precursor to mission planning. So we have great mission planning tools. We talked about them here today, QGC. We do the same thing. We iterate QGC and make it work for our users, like folks were saying. War Room is sort of a precursor to that. And so what we're doing with War Room is doing like mission rehearsal and sort of looking at scientifically accurate effects on target for some of our stuff in the defense side. It can be around, say, I want to design the perfect flight path, understanding thermals, understanding geography, and run simulation on that prior to actually creating our flight plan. And so War Room kind of sits, again, forward of QGC or to the left of QGC. But then the output from War Room, after you've done all those simulations and you're happy, if you're, say, a mission planner back home in the United States and you're working with someone in Ukraine, wherever it may be, you can do a lot of the work up front to make sure that they're going to have a successful mission prior to it actually happening. And then again, reducing the cognitive load on that mission planner that's at the operator level, at the tactical level. So say someone in intelligence can be prepping them with what they need. A bunch of stuff will get baked into War Room, but right now it's a lot of like simulations for visualizing kinetic and non-kinetic effects. That can be EW, that can be actual warheads and those types of things. But all digital allows our folks to operate this on a simple laptop, not needing a crazy computer or anything like that to run it. So War Room is exciting and will continue to be built out, and will be one of those products that actually like this community might over time be able to be involved in and help us with. Talked a little bit about Excel. It's evolved, so what you're seeing is a 40-foot Connex with all of our stuff in it. It's now to 20-foot expandable units. We like this visual because, I don't know, it's the best one we have in it. It looks kind of nice, so we've gone with it for now. But really, again, what Excel is about is additive manufacturing has always been king for distributed manufacturing, meaning like you don't have to have one fixed location producing all of your stuff. You can produce in a distributed network across the world, around the world. And Excel is just another node in that network, or another set of nodes. We are aiming to be able to produce at least 50 units of our Group 2 US out of Excel per month. Obviously, that depends on how many hours you're working, how many shifts, et cetera. And then when we go to Group 1s and that sort of space, it'd be more like 150, 200 vehicles per month type capacity. But the cool thing about the two system layout is we effectively have our manufacturing cell and then our finishing and assembly cell. And so you can have one finishing and assembly cell and then multiple nodes of the manufacturing cell around that, all feeding that same core. And again, we like this because of the tactical advantages that it has for the operators. Things are changing so fast. I might need to have my remote engineer solve some problem for me, send a part file forward to the front, have us producing a new vehicle in the next day. We might need to be that quick at making changes to our vehicle to be tactically advantageous on the battlefield. And then the other thing that it allows us to do logistically is really interesting, because we ship around these 20-foot Connexes on a C-17, C-130, something like that. They land, we're producing things. Now, feedstock materials, we use powder, right? So it's the densest thing that we can basically ship around. If you look at a 7-inch cube of powder, we can produce our entire aerostructure for that big Group 2 vehicle. So in a single ISU-90 container, which is a single pallet position, the powder that we can ship in there would produce over 2,000 airframes. The amount of airframes kind of semi-packed down, like wings off, et cetera, that we could ship in that same box is less than 100. So it's like you look at the logistics and the kind of, again, it's always a cat and mouse game with the enemy and how you get the most material into place. It's a very interesting asymmetric advantage that we want to provide to our folks and our allies. And that's just talking powder. Of course, you have like, your kits of all your other parts, the stuff you can't print at the edge, all of that. It's true that that's not just going to materialize out of nowhere. We know this well, trust me. But it's just nice to be able to, if you have these already in position, the replenishment is just a ride on anything. I mean, you could take duffel bags of powder and kits and still be making vehicles. So we like it as an asymmetric advantage. And we think we've created kind of the best mobile manufacturing platform out there that can do high volume manufacturing and is not just a lab. It's a true high volume manufacturing cell with workflows, everything that a technician needs to do their job well in an air-conditioned, controlled space. And so we're really excited about this. It's already in action. Just got back from some military exercises, and we're continuing to do more and more with it. And that is what I have. I wanted to leave at least a couple minutes maybe open to questions. But yeah, thank you all.
Do you have any questions? Yeah, James? You want to speak on the mic? Microphone again. Yeah. You want to be famous in YouTube or not? Sure.
Oh, so you're not just going to 3D print the wiring harnesses and the semiconductors and everything at the edge?
Yeah,
so
yeah.
I was curious, you said you offer electric ducted fan, internal combustion propellers, and jets.
Yeah.
What is the most popular, and sort of what are the advantages of all three?
Yeah, no, it's a great question. So we started with turbines because we kind of started in a space that was looking more like a cruise missile space, as you can imagine, starting in defense. We've gone away from that, but still, it's been a lingering propulsion source for us. I also love turbines just because it's thrust, you know what I mean? It's in pounds force or kilograms or whatever. It's just it's like an easier propulsion source. It's very linear. I love it for that. And it's low cost, right? In the prosumer world, there's maybe 20 small turbine manufacturers around the world. I can go get a turbine from every one of them and find one in the same or similar thrust class, where we're working on obfuscating away some of the ability to basically just like swap out even like for like turbines and be able to have our flight controller configure that exact same or that different turbine with the exact same settings, all that. So that's why I really like that. But it's limiting. Like the thrust-specific fuel consumption, their TSSC for turbines sucks. That's why you don't see any airliners with a turbojet anymore. Everything's got turbofans, but if anyone has seen a turbofan recently, the damn nacelle is the size of the fuselage, if you've seen vehicles. So I was just flying on a A350, I think, and I was just looking out like, my God, the nacelle's 15 feet in diameter. So that's really the reason why that's limiting. Ice pusher prop is probably going to be the creme de la creme for us because you get this just amazing range, amazing loitering times for doing things like ISR missions. And you can use diesel, simple fuels. Navy pushes you in the direction of like heavy fuels because they're very worried about fires for good reason. And then EDF has a very similar kind of performance map or flight envelope to the turbine, but it's just all electric if you don't want to deal with fuels. So pros and cons to all of them, and we just offer them up as different capabilities.
I also wanted to ask what sort of 3D printing technology you use. Now, if that's a trade secret, you don't have to answer.
Yeah, not a trade secret. So we use all layer-based technologies. I'll let the people online and everything look those up, but we use a few different. I come from a DLP startup, so that's digital light processing, effectively photopolymers using a projector to excite the layer and kick off the polymer reaction. I like layer-based technologies because they're fast as hell. They scale intra-machine versus inter-machines. Like if you're using FDM or some of these other technologies, fused deposition modeling or fused filament fabrication, one part takes 2 hours to print. If I go to 2 parts, it's now 4 hours. So that doesn't scale. It scales with systems. So you'll see some of our competitors running like print farms. But my God, if you've ever run a few printers and now you have to like 10 to 25 of them and keep them all in spec, and now your hot end's screwing up and you got like blockages, and it's a freaking nightmare. So if you can go industrial grade layer-based technologies, the scaling is incredible within a single system. And that's why we went there. And also if you have 1 of 25 fail in your print farm, you can't fly. Whereas if we have 99% uptime on our single big industrial printer, it's just much better from an uptime standpoint.
Oh, thank you.
Of course.
Anyone else have any questions? Yeah, back in the room. All right.
Thank you, awesome talk. Got a question about modular. How does flight dynamic change with different propulsion, different payloads, and so on? How do you manage that in the field?
Yeah, changes a lot, obviously, right? There's no free lunch in aerospace. It's unfortunate. But yeah, so we are basically building initially kind of like archetypes of vehicles. So right out of the gate, we're not like infinitely modular and infinitely configurable. There's a few archetypes. Those will kind of be built around the propulsion type. But we are really trending in a direction where someone could, as I said, like fully swap empennages and have a different capability Now, obviously, that requires a really robust autopilot, and so my autonomy team is, well, they're world class number one. They probably don't like me because I'm always throwing, wrenches at them. But yeah, it takes a very robust autopilot, and it takes different configurations for those vehicles. But if you have all those preloaded and the operator can very easily switch between them, or even better, our vehicle infers what propulsion type, what its weight and balance is feeling like, et cetera, from the dynamics of the vehicle, and can learn very quickly and self-configure. That's the future, and that's kind of the direction we're heading in. So, but you're right, it's a very difficult problem. No getting around that.
All right, everyone. Thank you, Ian.
Thanks, guys.